This is going to be part 1A of the collisions videos. It turns out that I accidentally skipped part of one of these slides, and it had some definitions that are going to be relatively important here. So I've gone back to this slide, which we kind of concluded part 1 on. And remember, the question was what happened to the kinetic energy that the trucks had, and there was a 300,000 joules roughly on them, and that energy had been transformed into other forms in the form of mechanical work due to deforming and those kind of things. But what we need to talk about here a little bit is the concept of elasticity and inelasticity in collisions. The word elastic in physics means that the kinetic energy is totally conserved. In the case of an elastic collision, then, if you have an object that doesn't change mass, its speed before and after will be unchanged. The total speed in the system, I suppose you could say, will be completely unchanged. So a collision that's pretty darn elastic would be billiard balls, because in the case of billiard balls, they hit, they bounce off, there's not much deformation, so there's pretty much elastic collision there. Also in the Newton's cradle thing where the balls that swing back and forth, pretty much elastic collisions. Perfectly inelastic collisions are one where the kinetic energy is completely converted into other forms. In reality, real-life collisions are somewhere in between. They're relatively inelastic. You would not see any perfectly elastic collisions in real life. If you remember some stuff from chemistry, there are things like in chemistry we assume that collisions between atoms are perfectly elastic, and that's what that meant.